In this section, we are going to look at the ways that Go allows you to control the logic in your program: if statements, for loops, switch statements, and functions. We'll also look at pointers and how they work in Go. For our first video in section 3, we're going to look at if statements and for loops in Go. You've seen them before in other programming languages, but Go adds additional features to make them more useful. Let's start with the if statement. Just like every other procedural language, Go has an if statement that evaluates a Boolean condition. If the condition is true, the statements inside of the if block are executed. If the condition is false, the statements inside of the else block are executed instead. If there's no else, then the program just continues. So let's see what that looks like in Go. Let's create a new project. Go, source, github.com, your username, and we'll make a new folder called learn if for. Open that up and create a file inside of it. Now let's put in some code. So here's our first program using an if statement. And if we open up a terminal now, and we run our program, not too surprised probably to realize it prints out a is bigger than 5. And there are a few things to note about if statements in Go. First, unlike most languages, you do not surround the condition with parentheses. If you want to try, you can, but when you save, GoFumped is going to run and just remove them. Next, the body of the if must be surrounded by braces. Some languages let you leave the braces off if it's only a single statement, but this is a horrible idea that leads to lots of bugs in practice. So Go just doesn't let you do it. Another thing that shouldn't surprise you, given Go's strong typing, Go doesn't have truthy values like some languages do. 0 is not equal to false and can't be coerced to false. So let's try making some changes to our code. If you said if 0, and you save it, you get back an error message there you can see from Visual Studio Code. And if we try to run it, we'll get the error message, non-bool 0, type untyped number, used as if condition. Also, if you type a single equals in an if comparison instead of using a double equals, it's a compiler error and not an assignment. So let's try that out. And we save that off. And if we try to run that, you can see there's already a red squiggle underneath it. We get back a syntax error, a equals 5 used as value. This is also a very good feature for avoiding bugs that pop up in other languages. And like many other languages, you can also declare variables inside of the body of the if statement or the else statement. They will only exist within the statement block because Go has block scope. So if you write some code that puts a variable in there, and we'll try that out right now. So if we run this code now, it will print out a is bigger than 5, 10 and 5, because the value of a is 10 and the value of b is 5. Now if we try to use that b after the if statement is over, or in the else, we'll get back an error. As you can see, it does not get the red squiggle. We try to run it, undefined b. Or if we try to use it inside of the else part, same thing. We'll get an undefined b inside of the else. So one thing that Go does let you do that you can't do in a lot of other languages is you can declare new variables before the comparison and use them in the comparison as well as in the body of the if and the else. If you try to use this variable outside of the if statement, though, you will still get an error because it's no longer in scope. So let's try this out now. And here we've declared b, part of the if statement, then a semicolon, and then the condition. And now, if you run this, we get b is less than or equal to 5, and 10 and 5, and b is visible in both the if branch and the else branch of our if statement. But if we try to access b after the if statement, that will still be an error. And we get back that undefined b. So that's if statements. They're mostly like the if statements you've seen before, only with a couple of neat tricks. And that brings us on to for statements. Most languages have a for statement for looping until something is no longer true, and Go is no exception. Just like most languages, a for statement has 3 parts: an initialization, a comparison, and an increment. And there's also a block that's executed until the comparison is no longer true. So let's give a sample of a for loop. And in this for loop, we count from 0 to 9, printing out each value. So let's try that out. And there's our output. You can scroll through and see all the values that came back out. Notice that just like the if statements, we don't have parentheses around the 3 parts of the for loop. You can see no parentheses here. If you want to stop incrementing through a for statement, you can use the break statement to stop early. So here's what one looks like. And when you run the code now, it will exit the loop early when the value of I is greater than 7. And if you want to skip over the rest of the body of the for statement and go back to the increment, you can use a continue statement. And here's what that looks like. And now, if we run our program, it will have printed out 0, 1, 2, 4, 5, 6, 7, 8, 9, skipping over 3. And so far, this is pretty standard stuff, but for statements in Go have a few tricks too. In most languages, there's a while statement that's used to loop until a condition is true. And rather than have a separate keyword for while, Go just makes the initialization and increment parts of the for loop optional. You can leave them off, and you've turned a for statement into a while statement in other languages. So let's see what that looks like. And if we run this code, you'll get back the values from 0 up till 10. And that's because I is declared outside of the for loop and is still visible after the for loop is over. But that's not all. The condition part can be left off too, leaving you with just the keyword for, running an infinite loop until a break or return statement is hit. So let's try that out. And so here we have our for, just a brace, no condition. And if we run this code, it'll print 0 through 11. So there's one more version of a for loop, and that's the for range loop. The for range loop lets you iterate over some of Go's built-in types. If you want to iterate over every character in a string, it looks like this. So let's take a look at line 7. That's where things are really interesting. We have for k comma v colon equals range s. And on the left side of the colon equals, we have two variables. And for every step through the range of s, we get back two values. The first one is the offset, which is the position inside of the string, and the second one is the rune. So remember, if you're printing out a rune, you have to do a type conversion to string to see the character, otherwise you just get its numeric value. So we're going to print out k and v and string of v, and let's see what happens. And we got back position, the number value, and the letter, all the way through hello world. And when you get to the end of the string, the loop just automatically exits. So notice I said rune and not byte. If you have strings with multi-byte characters, then a for range loop is the way to get to the valid runes. Remember the problem we mentioned earlier in our video course, where if you access the string elements directly, you are just getting bytes. So let's try this with some Unicode characters. We're going to change our hello world to our emoji representation of hello world. And if we save this and we run it, we get back 0 and the rune for the first wave. We get back 4 and a space, and then we get 5 and the number for the globe. Now if you notice, the offset is measured in bytes, not in characters. So it goes 0, 4, and then 5, because the first emoji is 4 characters long, and the space is 1 character long. And you can also use a for range loop to walk through an array, and there are other types that we'll talk about in section 4 that you can also use with a for range loop. And that's it! We've learned all about if and for statements in Go.